All right, 10.3 part 2. We have one more theorem today. It's the equidistant chords theorem. And that is talking about equidistance from the center. All right, so the equidistant chords theorem says that two chords are congruent if and only if they are equidistant from the center. We know equidistant means the same distance. So here we're equidistant from the center. We talked many chapters ago that the shortest distance between a point and a line is always going to create that right angle. So here, if these two pieces are equidistant, so if EG is congruent to EF, then those chords are going to be congruent. So chord CD is going to be congruent to chord AB. All right. So this next part is a little bit challenging. So we'll just kind of work our way through it. I want to find the radius, and this is the information I was given. QR and ST are the same. So these two chords are congruent, and they're both 16. CU is 2x right here, and CV is 5x plus 9. So I want to know what the radius is. The way we're going to do this is with the Pythagorean theorem. We're kind of going to zoom in on this triangle right here. So this diameter is perpendicular to this chord, so I know it's cutting these two pieces in half. So if the whole thing is 16, each piece should be 8. I want to know the radius. That's kind of what I'm missing. And UC is 2x. But I can't have two variables, so I'm going to need to figure out what x is. The way I'm going to do that is they're equidistant from the center, so that I can set those equal to each other. We can solve for x. So the first thing is 5x minus 9 equals 2x. Add 9 to both sides, I get 2x plus 9. Subtract 2x, you get 3x equals 9, so x is 3. And if x is 3, that means UC is 6. So again, we're looking at this right triangle here. This right triangle, we have 8, R, and 6. So we want to find what R is. So ABC, that's our Pythagorean theorem. A squared plus B squared equals C squared. We have 8 squared plus 6 squared is R squared. We want to know what the R is. So that's 64 plus 36. That's 100. And how do we get rid of squares? We take the square root of both sides. So that's going to give us the square root of 100, which is 10. So that is our radius. So we solve for x, plug it in, and then we use the Pythagorean theorem. So we're going to do just a couple more examples with those theorems we just learned. So first, we have this picture right here. There's a couple things going on. I have these two congruent chords. They're both 5. the degree of this arc is 40. So the first thing is, why is arc AD congruent to arc BE? So why are these two arcs congruent? Well, that's because their chords are congruent. That was the first theorem we did, the congruent corresponding chords theorem. All right, the next is find the value of x. Well, if these chords are congruent, I can set the x's equal to each other. So 15x minus 40 equals 10x plus 10. Add 40 to both sides. 15x equals 10x plus 50. Subtract 10x. You get left with 5x equals 50. And divide by 5, you get x is 10. And again, that's those arcs are congruent. Now it's saying find the actual measures of those angles. Well, we're going to take 10 and we're going to plug it in. Either one, if I plug 10 in here, I'm going to get 10 times 10 plus 10, which is 100 plus 10, or 110. You're also going to get 110 if you plug it into that one, because they're equal. And finally, what is the measure of BD? BD is this bottom one here. Well, this top one is 40. These are both 110. So those added up together give us what? 110 plus 110 would be 220, plus 40 is 260. And so BD is going to be what's left of that. So if I take that out of 360, I'm left with 100 degrees. So that's just using those theorems that we just worked with. And then just a couple more practices. One, I want to solve, these are all solved for x. So this is a diameter that's perpendicular, so I know it's bisecting. So these must be congruent, so I can set them equal to each other. This next one, this is 90 degrees, this is 90 degrees. I can set these equal to each other because they're all perpendicular, so all 4 of these would be, they're all radii. You can always set radii congruent. So 8x minus 13 equals 6x plus 9. Subtract 6x, you get 2x minus 13 equals 9. Add 13, you get 2x equals, what is 13 plus 9? 22. And so x is 11. And this last one, solve for x. The chords are congruent, so their arcs are going to be congruent. So once again, I can set those equal to each other. Subtract 2 from both sides, you get 150. Divide by 50, you get 3. So that is using those theorems. It's all about knowing what's congruent to the other. So now that you have watched this, you can go and do your 10.3 big ideas. All right, see you next time.